All right, so chapter 5, we're starting with composite functions. So that is going to be the f of x, g of x, and then we're making functions out of those. We're also doing the domain of our functions. Remember, domain is going to be all of your possible x values of a function. So if anything is going to cause x to be a 0 in the denominator, it cannot be part of the domain. For a radical function, you're going to set the values underneath the radical greater than or equal to 0, and then you're going to solve. And the domain is going to be given an interval notation. Okay, so for a linear graph, this is linear here. Your domain is always going to be negative infinity to infinity. Okay, because we're going to extend in either direction towards negative infinity and infinity. For a rational graph, what you are going to do is you're going to take that denominator, set it equal to 0, okay, and that's going to give you x equals -3. Meaning, if I plug -3 into the denominator, I would get 0, which means I'd have 5 divided by 0, which is invalid. Okay, so we say x cannot equal -3. So it's going to be all values except -3. If we look at this graph, we can see what it looks like. So I like sometimes to use this because it's prettier than the graphing calculator, because my graphing calculator is not colored. So this is Desmos, DESMOS.com. So if I put this into my graphing calculator here, this is really big. I'll make it smaller so I can see. Okay, so we have 5 divided by, and then x plus 3. So if we take a look at this graph here, okay, this is what we're looking at. So if we think about the domain, this is all of your x values. So this is coming from negative infinity and going up to this point here, which if I click on here, it's going to tell me that it's -3. It's approaching -3 as we get lower. And then we're coming from this value here, which is going towards -3 and to positive infinity. Okay, so our domain, the way we would write that, is going to be coming from negative infinity to -3, and then we use our union symbol, -3 to infinity. Okay, so we're approaching -3. We're never actually going to get there because if we did, we'd have 0 in the denominator. Number 3, you have a parabola, so this is always just as well going to extend both left and right. So this will also be negative infinity to infinity. And we can look at that if you'd like, but you guys have seen those several times. Number 4, okay, that is a rational graph. So what we would do is the same thing we did for number 3, set the denominator equal to 0, and then we can find the values and solve, or you can just put it in your graph. Let's see, let's put it in, and then you can look at those values. So you have 28 over, let's see what we have over, x, we got a little keyboard here, squared, minus 4x minus 5. And then we can take a look at what that graph looks like. So let's zoom in a bit. We're coming from negative infinity, and we're going up to this value here, which looks to be a -1. That's what we're approaching. And then we're going from that -1 to, let's see, 1, 2, 3, 4, 5. This value here. If you look, you can kind of see that as asymptote. And then 5 to infinity. Okay, or you could graph that. Or sorry, you did graph that. Or you can factor it. I get on my pen, and that would give you an x minus 5, x plus 1, which would give you the x values, positive 5 and -1. Okay, and then you would go from negative infinity to -1, because you would get to the -1 first if you're going left to right. Then you have -1 to +5, and then you have +5 to +infinity. Same thing for number 5, so we just cannot include here, that would be a +4, and here that would be a -6, because that would make the denominator 0. So if we go left to right, we're going -infinity to -6, then -6 to +4, and then +4 to +infinity. And then the square root graphs, you're going to set those greater than or equal to whatever's under that square root. You can also take a look just to show you guys what this looks like. This would be the square root, x minus 1, and there's your graph. So it can equal 1, and it goes towards +infinity. And I'm kind of going through this part quickly because this is review from the past couple of classes that you've had. Okay, so this is greater than or equal to 0. When you have the or equal to, you're going to use a bracket in your interval notation. So bracket, +1, +infinity. Okay, so let's take a look at composition functions. So you're going to have functions named f of x, g of x. Okay, you can do some compositions with them. So f plus g of x, you're adding them, just the two functions together. F minus g of x, f of x minus g of x, whatever order they're in. So if it was g minus f of x, you would do the other order. F g x, that's f of x times g of x. And then f over g of x is f of x divided by g of x. These are your two composition functions. Okay, this is what we're going to focus on a little more here. So this is f of g of x, meaning you're plugging g of x into f of x, and g of f of x, you're plugging f of x into g of x. Okay, so let's start with these examples here where we are looking at f of x is x plus 8, and g of x is 14 over x squared plus 2. So we have f of g of 4. Okay, so I'm going to write this like this, f of g of 4. When you're given a number value, I want you to start from the inside. So you're going to start by finding g of 4. Okay, so g of 4 means you're going to go to the g of x function, which is 14 over x squared plus 2, and you're going to plug a 4 in for that x. So that's going to be 14 over 4 squared plus 2. So we're going to compute that. That's going to be 14 over 4 squared is 16 plus 2, so 18. And then we're going to reduce that. Those are both reducible by 2. So 14 divided by 2 would be 7, and 18 divided by 2 would be 9. So we get that g of 4 is 7/9. Okay, since we're doing f of g of 4, now what we're going to do is we're going to do f of the 7/9. So you're doing f of g of 4, which is f of what g of 4 is, 7/9. So you're going to go to your f function, and you're going to say f of 7/9 is going to be 7/9 plus 8. And you can do that in your calculator. You can do it by hand. If I did this by hand, let's see. My denominator would want to be 9, so I could multiply this by 9 over 9. And that would be 7/9 plus 72 over 9, which would give me 79 over 9, which I don't believe reduces. But I'm going to check that. No reducing. So we have 79 over 9 there. Okay, so let's take a look at, well, we'll go over to example 3. So we have f of g of 2. So same thing. So I'm going to start from the middle with g of 2. So I'm going to find g of 2, which is going to be 14 plus 2 squared plus 2. So that's going to be 14 over 2 squared is 4, plus 2 would give us 6. And that would just reduce to divided by 2, 7/3. And then I have g of 2 equals 7/3. So I'm doing f of g of 2, then I'm going to take the f, and I am going to plug in 7/3. So we have f of 7/3 is going to be, let's see here, 7/3 plus 8. And I'm just going to go ahead and do this in here. So the fraction will go in parentheses, so 7 divided by 3, and then plus 8. And that will give you 10.3, which as a fraction, if I go math, enter, enter, 31/3. All right, and then we have f of 1. So now you're using the same function twice, and you're still going to follow the same pattern. So if I'm going f of 1, I'm going to start from inside, and I'm going to find f of 1 first. So f is x plus 8. So we're going to go f of 1 equals 1 plus 8. So that's going to give me 9. And then I'm finding f of 1. So I'm going to find f of 9. So f of 9 is going to give me 9 plus 8, which will give me 17. And then g of 0, same thing. So you'll start from the inside with g of 0, and that is going to be 14 over 0 squared plus 2. So 14 over 2 would give us 7. And then you're finding g of 7, and that's going to be 14 over 7 squared plus 2 will give us 14 over 49 plus 2, 51. And I think 51 is prime, so that's not going to reduce. Okay, and did we have to do the domain of these? No. Okay, since we were finding the numerical values, we're not doing the domains. Okay, and then we have example 2, where you would do the composition function and then find the domain. And I didn't put of x, but they should be just of x here, if you want to add that. Okay, so g of f of x. So you have g of f of x Okay, so now when it doesn't have a number in there, but it has the x, I want you to start from the outside. Okay, so do your g of x function. So you have g of x is going to be 5 over x, and then you're going to plug f of x into your g of x function. So you have g of f of x, which is 2 over x minus 7. Okay, so that is going to go into your g of x function like this. You're doing g of 2 over x minus 7. So you have 5 over this 2 over x minus 7. I'm going to take that, since it's division, I'm going to make this just a little bit easier here, and I'm going to go 5 divided by 2 over x minus 7. And then we'll do the division. So we'll keep the 5, change this to multiplication, flip this, and then we will multiply. And I don't think we need to multiply it out. We'll just leave it in factored form. So this will be 5 times x minus 7 over 2. What would the domain of that function be? Is there an x in the bottom? No, so it's linear, right? So that's domain going to be negative infinity to infinity, the domain. Okay, let's see what f of g of x looks like. So I'm doing f of g of x. So I've got f of x is going to be 2 over x minus 7. I'm going to plug g of x in for that x. Okay, so g of x is 5 over x. So doing f of 5 over x. That's going to be 2 over 5 over x minus 7. And that looks a little messy to me, so we can clean that up. 5 over x minus 7 over 1. Get a common denominator here, which would be x. We'd have to tack on an x here. So this would be, let's see, 2 divided by 5 minus 7x over x. And that still looks a little messy, so I'm going to do what I did here. Okay, so this is going to be 2 over 1 divided by 5 minus 7x over x. I'm going to flip this to multiplication. And we're going to have x over 5 minus 7x. So 2 times x will give us a 2x. And this will give us 5 minus 7x in the denominator. Okay, so then the domain of this does have an x in the denominator. So we would take this and set it equal to 0. So we've got 5 minus 7x equals 0. So let's see, we would subtract a 5 here. Negative 7x equals negative 5. So that's going to be a positive 5/7. That's going to be your restricted value there. Okay, so x cannot equal 5/7, which means our domain is going to be negative infinity to 5/7, and then union 5/7 to positive infinity. Okay, so go ahead and try these problems here. You've got 6x minus 3 and x squared minus 4. And that covers 5.1. So for our first one, we have f of g of x. So we are doing f of g of x. So my f of x function is 6x minus 3. So what I want to do is I want to plug g of x in for x. Okay, so I'm going to take the g of x function, which is x squared minus 4. I'm going to put it right here for this x. Okay, so if it were like a 2, I'd put a 2 in there. But instead of it being 2, it's this x squared minus 4. Okay, so I'm going to take x squared minus 4 and then that goes in for my x. And then I'm going to simplify it. So I've got, let's see, 6 times x squared, 6x squared, 6 times -4, -24, and then -3. And then that's going to give me a 6x squared minus 27. And then it's completely simplified. I do not need to solve. All right, and then coming over to number 3, I go out of order here. Since I already did f of g of x with the same problem, I can just put a 5 in right there if I want. So I can go here and say f of g of 5. I'm just going to take this 6x squared minus 27, and I'm going to plop the 5 in because that's what this is our f of g of x function. So we would go 6 times 5 squared minus 27. And 5 squared is going to be 25. 6 times 25 is going to be 150. Minus 27 would give us 123. I could do it the other way too if I want. It's up to you guys, however you want to do it. If I did f of g of 5, I could start with g of 5, and you should get the same thing. So g of 5, I put 5 into my g of x function. So 5 squared minus 4, so that's 25. Minus 4 would give me 21. And then I do f of g of 5, so I'm doing f of 21. So f of 21 is going to be 6 times 21 minus 3, which would be 126 minus 3, 121, or 22. So either way, you would get 123, and whichever way you want to do it, that is up to you. Okay, so g of f of x, taking a look at this one here, so you have g of f of x. So my g of x function is x squared minus 4. So I'm going to take this x, and I'm plugging f of x right there. So f of x is 6x minus 3. So this x is going to become f of x, which is 6x minus 3. And then I'm squaring that and subtracting 4. Okay, so f of x goes into the g of x function. Then I'm going to take that and I am going to work that out. So I'm going to do 6x minus 3 squared, so times itself, and then I'm going to subtract 4. So let's see, we've got 6x times 6x will give us a 36x squared. 6x times -3, negative 18x. Negative 3 times -6x, negative 18x. Negative 3 times -3, positive 9. Bring down that minus 4. And let's see what we get here. We're going to get a 36x squared minus 36x and plus 5. Okay, and then g of f of 1, I already did g of f of x, so there I can just plug the -1 in. So let's go ahead and do that. We're going to go 36 times -1 squared minus 36 times -1 plus 5. So -1 squared is positive 1 times 36 would give us a positive 36. Negative 36 times -1 will give us a positive 36 plus 5. So 36 plus 36 plus 5 should give you 77. Question? Yeah, you could do it the other way if you'd like. Do you want me to do it the other way? Okay. Let me see where I have room. I'll probably do it over the side here. Okay, so g of f of -1. So I'm going to do f of -1 first. So that would be, what's the f of x function? 6x minus 3. So 6 times -1 minus 3. So -6 minus 3 would give me -9. And then I'm going to do g of f of -1. So g of -9. And then my g of x function is x squared minus 4. So I'm going to go -9 squared minus 4. So 81 minus 4 gives you 77. And then the next one is just graph, FYI. There's some homework stuff like this. I'm not going to put something like this on a test or quiz, but it's just looking at the graph. So with the numbers here. So you're doing the same process as what we did right here. So you're going to go g of f of -1 and start from the inside. So notice that this is your f of x graph, the bottom one. The top one is your g of x graph. So you're going to start at f of -1. So f of -1, meaning when x is -1 on the f graph, what is g? So I go here and I look at it and I say, here's -1. Okay, that y value is 0. Your output there is 0. So f of -1 is going to be 0. And then you do g of 0. So then you're going to go to your g graph, and you're going to say, well, g of 0, here's where x is 0, is going to give me a y value of 7. So g of f of -1 is 7. And then same thing here, so g of f of 0. So start with f of 0. So let's see, 0 on the x-axis and the bottom graph is going to be 1, 0, 1. And then g of 1 is going to be, here's 1, 6. So that'll give you 6. Yeah. Oh, and a positive 1. Thank you for pointing that out. Well, let's fix that then. I could just change it to a positive 1, but I won't. Okay, so -1, that's going to be 2. So yeah, that's going to change things. Okay, so then g of 2, here's 2. That'll give you the 0.4, so 2, 4. So yes, the answer to number 1 should be 4, not 7. If it were f of positive 1, it would be 7. Okay, so then number 3, you have f of g of -1. So start with g of -1. So -1, 5. And then f of 5. So 5 on our x-axis is right here. And that looks like that is -4. And then number 4, you've got f of g of 4. So we'll go to g of 4 first. So 4, and then our g is right here. That looks like that's going to be 4 as well. And then f of 4 is going to be -3. So that's why I'm not going to put it on test. This is super easy. Too easy. Okay, so anybody have any questions for 5.1? All right.